Here we found the two square roots of this complex number in the previous video. It's z equals 3 plus j4. I'm going to ask you to find, well, I had asked you to find the 3 cube roots of z. Alright? Now, I trust that you have already done so. If not, pause the video right now, write it down, and make an attempt at finding the 3 cube roots of z before watching the rest of it. Okay, so you've done that. You found the 3 cube roots of z. So let's go. We use De Moivre's theorem. Here we're going to write z in polar form. The polar form is z is equal to r. We could open the bracket. We could use brackets, as in this case, as usual, cos theta plus j sine theta. But this is the same thing as r cos theta plus j r sine theta, right? Remember that. So you should remember your polar and rectangular form. And remember, just a quick review. If you have r, you have x and you have y. This is theta, right? Now, this is right angle, although it doesn't really look like it. Let me make it looking more like a right angle. And you remember that sine or cos theta is the adjacent x over the hypotenuse r. So when you transpose x is equal to r cos theta, so that's where this comes from. And sine theta is opposite, which is y over hypotenuse r. So when you transpose to make y the subject, y equal r sine theta, which is where this comes from, right? Just a quick review there. But here now, r is the square root of 3 squared plus 4 squared. You're going to get 5. And theta, tan theta is opposite over adjacent y over x. So theta is tan inverse of y over x, which is 4 over 3. Which is, what was it again? Tan inverse of 4 over 3 is tan inverse of 4 over 3 close bracket equal 53.13 degrees. All right. Now, what De Moivre's theorem says is that z to the power of n is r to the n, just raise r to the n cos n theta plus j r to the n sine theta, sine n theta. We're just using it in this form, the expanded form, rather than the bracket, but it doesn't matter which one you use. The bracket one, it's neater, right, well put together. It's compact, but sometimes I like using the part without the form, without the brackets, right? Alright, so we want the cube root. So the cube root of z is the same as z to the 1/3, which is r to the 1/3 cos 1/3 theta. 1/3 theta, let's put it this way, is the same as theta over 3, alright, plus j r to the 1/3 sine theta over 3. Alright? So that's what we have. Now, you probably will see the formula somewhere that says that the nth root of z is equal to the nth root of r cos theta over n plus k 360 over n, right? Plus j sine theta over n plus k 360 over n. And most time they would compact it and say theta plus 360k over n. I'm writing this formula because it's a common formula you will see. Alright? When you're working in radians, you would see 2 pi instead of 360. Right? Now, for the first root, k would be 0. Second, so you don't have to use it. For the second root, k would be 2, and so on and so forth, right? That's the formula, but let's not concentrate on that formula. Let's do what we have to do here. Cube root. So let's say this is cube root of z. 1. First cube root is going to be, what's r again? Oh, it's r, it's going to be 5, the cube root of 5 cos theta over 3, 53.13 over 3. Alright, you don't have to worry about the 360n yet because it's 0 times it, plus j sine 53.13 over 3. So the first cube root of z is going to be, what's the cube root of 5 again? Let's find it. Cube root of 5. Alright, there's no direct cube root here on this calculator, so I'm going to say 5 raised to the power of, open bracket, 1 over 3, close bracket. That's the same thing as cube root of 5. 1.71. And then after that, we see that 53.13 over 3. 53.13 divided by 3 equal 17.71. 1.71, 17.71. So 1.71 cos 17.71 plus j sine 17.71. Alright, so you see that so far. Cube root of 5 times that. Alright, so remember here we had 5 to the 1 over 3, same as cube root of 5. Alright, so you see that that's what we have so far. Remember, we said 1.71 to the power of 3, we should get 5. 1.71 raised to the power of 3. We get 5. Nice. But anyway, we have this. We could just turn it into thing there now, into back into rectangular form. Let's work that out. 1.71 multiplied by the cosine of 17.71 equal 1.629, and then one point, oh no, 1.71 multiplied by the sine of 17.71 equal. Alright, so we have 1.62, call it 1.63, 1.63.52, 1.63.52, 1.63 plus j 0.52. Alright, so that's what we have so far, right? For the first cube root. Remember now, there will be 3 cube roots equally separated from each other. So we'll have, in our Argand diagram, we have our circle. There will be 3 of them. This angle is 17 point that. So we can picture this circle and the first cube root, right? Let's draw our 4 quadrants for the circle. We have our first cube root. So this is Z1, represented by our first cube root. Now, here, the circle is divided into 3 equal parts. That is 360 over 3, which is what? 120 degrees. So we have our 17.71, then 120 degrees. If we rotate, add this to 120, 20, that's 137 point something. It would come here. So the next one should be somewhere here, and then another 120. This one should be somewhere here, right? So, but we'll see how it goes. All right, so the cube root of z, the second cube root of z, going to be 1.71 cos. I had used a bracket. Let me not use a bracket for this one. Cos 17.71 plus 360 over 3, which is plus 120. So we need to rotate, plus j 1.71 sine 17.71 plus 120 degrees. So remember, after we find the first one, we have 2 more. They must divide the circle equally, so we rotate it. Each is separated by 120 degrees, all right? So what we have here now is 1.71 cos 120 plus this. That's 137.71 degrees plus J sine 137.71 degrees. Alright? So we found the rectangular form for this. Let's find the rectangular form for Z2. Alright? So back to our calculator. So we have here 1.71 times cos 137.71 okay, negative 1.26 negative 1.26 plus J. Alright, let's see what the other part of it looks like. This would be sine now. 1.71 times sine 137 point that. That's 1.15. Alright? Plus J 1.15. Let me look back at it. Right. What was this thing? Yeah. Let's look back at this. Yeah, 1.15 positive. Alright. Now, the third cube root of Z, 3 now, is equal to 1.71 cos. So it's 17.71 plus 120. One rotation of 120 to find the second one, plus another rotation of 120 to find the third one. Right? So it's two rotations. It's like we have this, right? I rotate it. Oh no, let me put it here. What's going on? Alright, let me put this line there. So, let me extend this line, make it a little longer. So if we have this line, we rotate it 120 degree, and then we rotate it again. If we do another third 120 degree, it would be 3 of them. Right? So that's what would happen. So I have to rotate twice, but this would be the same as 2 times 120. So for the third cube root, it's 2 times this. So for the first cube root, there is 0 rotation. For the second cube root, there is 1 rotation. For the third cube root, 2 rotation around the angle 120. Alright? So plus J sine 17.71 plus 2 times 120. Let me write this part a little neater, so you can see the 2 times 120. Alright? So this is 1.71 cos 17.71 plus 2 times 120 is 240 plus J sine 17.71 plus 240. So it's 1.71 cos. This is what, 240, 250 257.71, right? Plus J sine 257.71. So we have that. I don't really need these brackets around the number. Why did I bother to put them? But anyway, let's convert this into rectangular form now and see what the rectangular form looks like. Where am I getting all of these calculators? Let me go back to my original calculator, right? So here now, I have 1.71 multiplied by cos 257.71 and get negative 0.361, and then 1.71, and this time it is sine 257.71 equal negative 1.66. So negative 0.36, negative 1.3 minus 0.36 minus 1.66 minus 0.36 minus 1.66. Well, it's minus J, right? It's minus J 1.66. All right. So let's now look at the thing there, the Argand diagram for the 3 cube roots. All right. So this diagram for the 3 cube roots, I have one of them. The first one, 1.63 plus J 0.52. Let me make our quadrants first. So 1.63, what is it? 1.63.52, something like this. The angle there is 17.71 degrees. All right, this angle 17.71 degrees. So this is cube root Z1. Where is cube root Z2? The second one. Negative 1.26 plus 1.15. So it's negative 1.26, 1.15, something like that. All right. So this is the cube root of Z. Second one. What was the angle again? 137 point something. So this angle 137 point that. All right, 137.71. And then the third cube root, the angle was 257 point odd. This is 270, 257. Not too close to it, but kind of close. Right? And that's negative 0.36, 1 point something. All right. So as you see here, the first cube root, it to the right 1.63, up 0.5 something, all right? So do the right 1 point some, 0.5 something, and the angle is 17.71. The second cube root, it went to the left and up, to the left 1.2, up 1.15. It goes to the left and then up, and the angle 137 from here is 137.71. And then the third cube root is to the left and down, as you see here. What, 0.36 to the left and down 1.667, and the angle 257 point something. So this angle 257 point something, right? So they would be separated by 120, 120, 120 degrees each. So you can see that, all right? So we have the three cube roots, and we have them in polar as well as rectangular form. All right, good. So that's it for now. I'll see you in the next video.